All right, so this is section 8.1, which is Introduction to Vectors. So first off, what a vector is. A vector is a quantity that has both magnitude and direction. Magnitude is just another word for length, so it has length and direction. So if you look at this right here, this is a vector. We could call this vector PQ. So the starting point right here would be P. And then there is an ending point. So vectors do end. They end at where the arrow is. So this would be Q right here. The arrow doesn't mean it goes on forever. The arrow is just showing the direction that it's going. So the starting point would be P and the ending point would be Q. Vectors are graphically represented with directed line segments. So this is called a directed line segment. It does have a beginning and an end, therefore it's a segment, but it's directed. It has direction. It has an arrow showing which direction it's going. Given vector V above, so we can also call this with one lowercase letter, which would be something like that, V right there. Another name for V on this one that we just drew right here would be vector PQ. So you would write vector PQ just like you would write array. So your starting point to your ending point. P would be the initial point. And Q is the terminal point. So once again, that's vector PQ or vector V. P is the initial point. Q is the ending point, the terminal point. The arrowhead is the direction. So the direction is your arrowhead. And then the magnitude of V is the length. So keep that in mind. Magnitude is the same thing as the length of V. Magnitude is denoted, it's notated by double lines onto the left and to the right of the name. So this right here, these double lines right here on each side, that means magnitude of V. All right, so next it says, find the magnitude of vector V graph below. So vector V graph below, that's vector PQ right here, so vector V, all right? I want to find the length of that vector. So notice it goes from one point to another on a diagonal, so I can't count. But I can count vertically and horizontally, make this into a right triangle, and use Pythagorean Theorem. So if you connect P to Q at the vertical line and a horizontal line instead, you created a right triangle. And you can see that this length is 1, 2, 3, 4 right here. And this one is 3. So you can use Pythagorean Theorem to find the length of vector V. So in order to do that, we would do 3 squared plus 4 squared equals V squared and square root. So instead of doing that, what I'm going to do is say to find the magnitude, all you have to do is the square root of, so I'm going to square both sides already, a squared plus b squared. Okay, and so instead of doing a squared plus b squared equals c squared and then square rooting both sides, I call it V for vector. And I'm going to square root both sides already. And you don't have to do plus or minus because it's a length. It's always positive. So our vector length would be square root of 3 squared plus 4 squared. That's the square root of 9 plus 16, which is the square root of 25, which is 5. So the length of vector V is 5. All right, two vectors are equal if they have the same direction and magnitude. So they'd have to be the exact same thing. They can be on different places on the graph paper though. This says draw vector W with initial point 4 so that V and W are equal. All right, so we already have N drawn here and I want it to have a length of 5. So I'm gonna use the idea that it goes up 4 and right 3 to help me get the terminal point, and then I'll just connect them. So I'm going to go from V, I'm going to go up 4 and then right 3 and make my point. And I'm not going to keep those lines there, but it's just so that you can see what I'm tracing from. I'm going to start at N and connect it to that terminal point right there. And then I'm going to put the direction showing that. And it's said to call that W. So there is vector W that is equal to vector V. Next vocabulary is opposite vectors. Opposite vectors have the same magnitude, so they have the exact same length. They just have different directions or opposite directions. So we're going to draw the opposite of V, or negative V, with initial point R. Okay, so you want it to have the same length. So instead of going up 4 and right 3 and being off the graph paper, I am instead going to go down 4 and right 3, or left 3, sorry. I'm going to go down 4, left 3, make a point right here. That's going to give me a length of 5 still. So same slope, right? Okay, if you look here, this is up 4, right 3. Okay. I'm going to connect those 2 points. Okay, but it has different directions. So my initial point is going to be R, and it's going to go in this direction. So this is negative V, or the opposite of V. Okay, so same slope. Keep that in mind. This is going to, opposite vectors have the same exact slope, but different, or arrow points in the opposite direction. Arrow, opposite direction. Also keep in mind that the slope of, like how you can do 4/3 for the slope, which is equivalent to -4 over -3, and that's what I did. All right, next it says draw the 0 vector. A 0 vector has a length of 0, so it's just a point. So this is what the 0 vector looks like. And then another vocabulary word is a scalar. A scalar is a real number, a quantity with only magnitude. So 6, 2. Okay, so this is operations with vectors. So we're going to be using a graphing method, and we're going to do addition, subtraction, and scalar multiplication. So example 1, it says, given vectors u, v, and w, complete the following. So we're going to do v plus w, w plus v, v minus w, w minus v, so on and so forth. So if you look ahead, notice that we're going to need the opposite of v. So what I'm going to do next to these drawings of v, u, and w, I'm going to draw their opposite vectors too, so that I can use those in the future. I think this is a really good idea, okay? All right, so if you look at this, this goes up 1. This goes up 1 and over 1, 2, 3, 4, 5. That's the end right there. So I'm going to do the same thing to make the opposite of v, or negative v. So I'm going to draw a point, and then I'm going to go up 1 and over 5. 1, 2, 3, 4, 5. And then I'm going to connect those 2, but I'm going to draw the arrow pointing in this direction, and that's the opposite of v. Then I'll do the same thing for u. It is a vertical line with a length of 2, so I'll draw a vertical line with a length of 2, but the arrow will point in this direction, and this is negative u. And then if you look at w, it has a slope of down 3, right 2. Down 3, right 2. So I'm going to make a point, go down 3, right 2, but then I'm going to go from the second point to the first point, and that is the opposite of w. This will help me when I'm doing this, so I can just look at the picture and say, okay, this is how it looks. All right, so the first one is I want to do v plus w. So what you're going to do is you're going to draw v. Please don't copy and paste, because on your test you can't copy and paste. You're going to have to actually copy the drawing. All right, so I'm going to start by drawing v. So I'm going to make a point anywhere I'd like to. So I'll just make a point right here. And I look ahead, and I know v right here has to go up and to the right, so I don't want to start it over here because I'm going to run out of room. So I'm thinking ahead before I actually do. All right, so I pick a point, and I have to go up 1, right 5. So up 1, right 5, make another point, connect those 2, show the direction, and that's v. All right, now I have to do plus w. So I'm going to change colors so you can see this, but I'm going to start at the terminal point of v. So I'm going to start right here, and this is where w is going to start. So for w, I have to go down 3 and right 2. So I'm going to go down 3, right 2, make an ending point. And then I'm going to show the direction, which is this. That's w. And now I'm going to draw v plus w, because I haven't even drawn v plus w yet. To draw v plus w, go to your initial point where you started, which is right here, and draw it to your last point you drew, which is this terminal point of w, which is right here. So this is v plus w. Okay. All right, let's try another one. That's called tip to tail. That is when you just draw from using v plus w. You could also use w plus v. So I'll show you that. You can do v plus w and w plus v. So I'm actually going to copy this. Copy, paste it over here somewhere. Like, make sure that it fits. There we go, and that you're on intersections. All right, so if you wanted to do w plus v, you could also do w plus v at that same starting point, because v plus w and w plus v are the same thing. So if I start at the same exact starting point, I should be able to do w plus v and end right here and get this vector right here. So let's see if we can do that. So we're going to do w plus v instead and start at the same initial point. So I'm going to do w. So w is right here. I'm going to go down 3 and right 2. So I'm going to go down 3, right 2, and now I'm right there. And this is w. Now I have to do plus v. So remember where you're at. You landed here. So now I have to do v. If you look at what v is, it's up 1, right 5. So I'm going to go up 1, right 5, and notice that you do end right there. And then to get your vector, w plus v, you go back to where you started, which was right here. Connect that to the end and show your direction. So this is w plus v. So notice that v plus w is the same thing as w plus v. This is just showing tip to tail, meaning that I only did v plus w. This is doing v plus w and w plus v. You only ever have to do one of them. All right, now we're going to do v minus w and w minus v, which are not the same thing. It's the same idea that 5 minus 2 and 2 minus 5 are not the same thing. All right, we're going to start by drawing v, and then we'll do the opposite of w, or negative w. So we're going to start by drawing v, which is right here. Draw a point, and then go up 1 and to the right 5. Draw a point, and go up 1 and to the right 5. Connect those, put in your direction, that's v. And now I want to go the opposite of w. So if you look at where the opposite of w is, it's right here. So from this point right here, so this is my starting point now, right? I want to go up 3, left 2, right, to get there. Up 3, left 2. Now if you look, I'm going to run into what I have here, so I'm just going to move this down because I didn't think before I did it. And now I'll do it. All right, so from that purple point, I'm going to go up 3, left 2, and the direction is this way, and that's the opposite of w. All right, and now I want to show v minus w. What I'm going to actually do is move this w here first because I just feel the need to. And now I'll show v minus w. So I'll go to your initial point, to your terminal point, your last point, and that is v minus w. Okay. All right, now we want to do w minus v. So let's think ahead before I do this so I don't have to move it again. So I'm doing w first, which is starting at a point and going down and to the right. And then I'm going to do the opposite of v, starting at a point, that next point, and going down to the left. Okay, so I'm going to start here, let's say. All right, I have to do w. W is this orange circle one here, so I have to go down 3 and right 2. Down 3 and right 2 and make a point. Down 3, right 2. Draw your direction, and that is w. Now I have to do opposite of v. Opposite of v is right here. This is where it starts, so I'm going to do my starting point right here. And then I have to go down 1, left 5. I'm going to go down 1, left 5. Down 1, left 5. 3, 4, 5. Right there. Down 1, left 5. Right there. And then that's where I start. That's where I end. There's my arrow. That's the opposite of v, not w. And now I'm going to show w minus v. So I'm going to start at my first point at w and then go to the terminal point of the opposite of v. And this is w minus v. Okay? So notice the triangles are congruent. They look the same, but if you look at the direction, they're not the same. It's the opposite direction. This one, this w minus v, this is the initial, this is the terminal, and vice versa here. This is the initial, this is the terminal for v minus w. Okay. Next we have 2w. So this is a scalar multiplier. So what we're going to do is we're going to draw W twice. So W starts at a point, initial point, and then it goes down 3 and right 2 to get to your terminal point. So I'm going to start at a point, and then I'm going to go down 3, right 2 to get to a terminal point. And then I'm going to do that again because it says do it twice, right? So I'm going to go down 3 and right 2, and there's the ending point. So this is 2W. And what I could do here is get rid of the arrow here because it's implying that it's going for, that direction already, and there's 2W. All right, last one, I have to do W, and then minus 3 times U, minus 2 times V. Okay, I'm going to try to think before I do so I can start out in a good place. So I have to do W, which is this, so I start, go in that direction. And then I have to do the opposite of U 3 times, so then I'm going to go up U 3 times. And then I have to do the opposite of V twice. So that's that direction. Okay, so I'm going to start pretty low here. I'm going to start like down here and hope that there's enough room. If not, I'll move things. Not a big deal. Okay, let me erase all these things I circled and highlighted so that they're not in my way here. Okay, so I'm going to start by doing W. W is start at a point, go down 3, right 2. So start at a point, go down 3, right 2. There's the direction of it. Hopefully I don't fall off the end of this, and that's W. All right, now I want to do the opposite of U 3 times. So the opposite of U is right here, and I want to do that 3 times. So I'm going to start right here at the terminal point, and the opposite of U goes upwards. So I'm going to go up 2 3 times. 1, 2, 3. So I'll end up right here. And this is minus 3U. All right, lastly, I have to do the opposite of V twice. The opposite of V twice. So where's the opposite of V? Right here. I got to do that twice. So start at your last point that you drew and go down 1 and left 5. So I'll start here, go down 1, left 5, and then I got to do that again. Down 1, left 5. 1, 2, 3, 4, 5. And this is where I'm going to end. So I'll come here, connect those, show my direction, and this was negative 2V. All right, now I want to draw the vector, which I go to where I started, which was right here, my initial point, and then where I ended my terminal point. Connect those two, and then show the direction, start to end. Start to end. And there's your vector, which is W minus 3U minus 2V. Okay? All right, next it says, given the diagram, answer the following questions. So the first one says, express L in terms of A, K, and E. So here I want to use A, K, and E to represent L. So let's find L first. L starts here, ends here, right? And it goes in this direction, okay? All right, so I want to use A, K, and E to represent that. So here's A, here's K, and here's E. So I'm going to go from the start to the end and say if I'm going in the opposite direction or the same direction. All right, so I'd have to start here, and that means I'd go in this direction first, and that's A, okay? And now I would go and follow this way, and that's a positive K, so plus K. And I'd go in this direction, which is the same direction E's going, so plus E. So A plus K plus E. All right, let's try another one. Express E in terms of F, G, H, and J. So here's E, it starts here, ends here. All right, I want to use F, where's F? F, G, H, and J. All right, so I'm going to go to where E starts. E starts right here. I don't want to use a highlighter, I want to use a color, sorry. All right, so it starts here, and I got to follow this path first, which is F, and it's in the right direction, so it's just F. And then I'm going to follow this path right here, and that's G, and it's in the proper direction, so I'm going to do a plus G. Then I'm going to follow this path right here, and that's H, and it's in the right direction, so it's plus H. And then I'm going to follow this path right here, which is in the wrong direction, so it's the opposite of J, so minus J. See that? These are pretty quick, right? Okay. Next one, find x if x is a plus b plus c. So I'm going to highlight a, b, and c, or I'll actually just say I'm starting here. I'll put an S for start. And then I'm doing a plus b plus c. And this is my end. So I want a vector that starts here and ends here. So that's this vector, and it's the right direction for start to end. So that's D. All right, the next one here, I'm going to do it the same way. All right, I have to use K and the opposite of D. Okay, so where's K? There's K. K starts here, so that's S for start. I'm going to do K, and then I want to go in the opposite direction of D, so that's following it this way right here, and this will be my end. So I want to know the vector that starts here and ends here. That's A, but notice if I want to start here and end here, I have to go in the wrong direction. So that's the opposite of A. Okay? All right, so this is pretty similar to that. Example 3 in the diagram, ABCD is a parallelogram. Okay, that's good to know. AB is X, that's already labeled, and AD is Y, that's already labeled. Express each vector in terms of X and Y. Well, since this is a parallelogram, I also know opposite sides are congruent. So if AB is X, CD is going in the same direction too, if you look. It's going in the same direction. So CD is also X. It's not the opposite of X. It's the same direction. So I don't know why I put C there. I meant to put X. All right, and then this and this and this are the same. And if you look, they are going in the same direction, so they're both Y. So I'm going to put that in there also because it should be helpful. All right, so it says express each vector in terms of X's and Y's. All right, so it says, what about vector BC? BC starts here, ends here, and that's the same thing as Y. So Y. All right, next one, number 2, AC. AC. AC starts here, ends here. And I need to figure out how to say that because that's not labeled with X's and Y's. So what I'm going to do is I'm going to use two vectors to do that. I'm going to say it starts here, and I have to get to this end. So I can take this path. I'll take this path right here. That's X. And then I'll take this path right here. That's plus Y. So X plus Y. All right, next one, CD. CD. CD starts here, ends here. If you look, CD doesn't go in that direction. It goes from D to C, and I want CD, which is starts here, ends here, so I have to go the opposite of that. So this is the opposite of X. All right, next one, AO. AO starts here, ends here. All right, well, I can't get to that path, but what I can do is I can take the path. Like, there's nothing I can, like, take this path, but I don't know this one right here, so that's not going to work. So what I can do is I can say I can take this path from here to here, start at A, end at C, but then take half of that. So I'm going to do start at A, go to B, which is X. Now I'm at B, and I need to go to C, which is Y, so X plus Y. And then it's just half of that path. So X plus, oops, I wrote it in the wrong spot. X plus Y divided by 2. All right, BO, let's try that one now. BO, BO. Oh, so same idea. All right, so I'm going to start at B, and I'm going to go this direction. That is Y. And then I'm going to go this direction, which is the opposite of X, because this points this direction, right? So that's minus X, and then it's half that distance, so divided by 2. Okay, a little bit more vocabulary, and then we're done with notes for today. So next vocabulary word is a unit vector. A vector that has a length of 1 is called a unit vector. So that's what this says right here. This says length of 1. Length or magnitude, right? Length or magnitude of 1, that's called a unit vector. All right, next it says, let I be a vector with direction along the positive axis, so that's I, and it's going to have a unit length of 1. And let J be a vector with the direction along the positive axis where that is 1. If vector v with an initial point at the origin and terminal point AB, then vector v can be represented in terms of I and j. So if you look, basically we're trying to start here and then go to where they meet right there, where they would meet if they went this way, okay? So how we can represent that is v equals a times I plus b times j. A and b right here are called the components. A vector whose initial components, sorry, I just skipped the position vector. So a position vector, this is a position vector right here. Its initial point is at the origin. So it starts at the origin and then goes to another point. Okay, that's called a position vector. Also, please keep in mind that this distance is A and this distance is B right here. So it's really easy to write this vector. We would do V equals, if A was 5, we do 5I. And then if B was 6, we do plus 6j. That would be the vector for that. It's nice. Nice and easy. Okay, so we have a theorem, and it says, suppose that a vector v has initial point of x1, y1, and a terminal point of x2, y2. Then we can write an equation for the position vector by using the form v equals a times I plus b times j. And we can get a by doing x2 minus x1, that's what it says right here. And then for the b value, we just have to do y2 minus y1. All right, so you'll see that this is super easy. Example 4 says the vector v has an initial point at negative 3, 6 and a terminal point at 1, 2. Find its position vector. So to find the position vector, we just have to use this formula right here. Okay, so we're going to do v equals, to get the a value, we're going to take the x values and subtract them. This is x1, y1, and this is x2, y2. So we're going to do x2 minus x1. So 1 minus, and then a negative 6 turns it into plus 6. And that'll be I plus, and then we're going to do the same thing for the y values to get the b value. So that is negative 2 minus 3, and that's for the j part of the vector. So we have v equals 7I. That's a negative 5, so instead of doing plus negative 5, I'm going to do minus 5j. And that's the position vector. So if I wanted you to draw it then, like if I wanted you to move it to the origin, you can say it starts here, it goes up, it goes right 7 and down 5, and it goes like that, and there it is. There's your position vector. Okay? And it's just the same vector that has points negative 6, 3, 1, negative 2. It's just moved, so the initial point is at 0, 0. Okay. Last but not least, adding and subtracting vectors, super easy. To add, subtract vectors, you add, subtract the corresponding components. The components, once again, are the a values and the b values. So if I have vectors v equals 9i plus 4j and w equals 7i minus 6j, if I wanted to add v and w, I would add the I values. So I have v plus w is equal to 16i. And then I would add the j values. A positive 4j and a negative 6j is a negative 2j. So 16i minus 2j. If I wanted to subtract them, I would just subtract those two values. So 9i minus 7i is 2i. And then 4j minus a negative 6j, 4j minus a negative 6j is 10j. So 2i plus 10j. Last but not least is scalar product. It says to multiply a vector v by a scalar, we multiply both components, which is a and b, by the scalar. The resulting vector will have a magnitude, absolute value of a times that of v. So if you multiply it by 3, it'll be 3 times as long as the original vector. If a is negative, it's going to change direction also. All right, so it says given the vector v equals 5i minus 4j, you're going to multiply it by 3 and take the opposite of it. So all we have to do that we have negative 3v is equal to, you're going to multiply the scalars by negative 3. So that's negative 15I plus 12j. And what would happen there is that it would change direction and it'd be 3 times as long. All right.